Let us find out the value of speed which is greater than the most safe speed on a rough curve road. Here, this is a vector diagram for a vehicle on a bank road. In this case, if you see, the force of static friction between the road and the tire of a vehicle is directed along the inclination of a road acting in a downward direction. We resolve this Fs component into two component. Its horizontal component is F cos theta. Its vertical component acting downward, that is Fs sin theta. We also resolve the normal reactant component into its two components. Vertical component is n cos theta and horizontal component is n sin theta. This is acting towards the center of the curve road, and also it is directed towards the centripetal force. So it is found that the horizontal component of the Fs, that is F cos theta, and the n sin theta both are parallel to each other, and these two forces take care of necessary centripetal force, which must be greater than the component n sin theta. In this vector diagram, component n cos theta balances the two parallel downward component Fs sin theta and mg. So we can write the equation as n cos theta equal to mg plus Fs sin theta. Rearrange this equation. We can write mg is equal to n cos theta minus Fs sin theta. Also, it is found that n sin theta and Fs cos theta, they are parallel to each other and they balances the centripetal force, and hence we can write the equation 2 as m v2 square upon r is equal to n sin theta plus Fs cos theta. Divide the equation 2 by 1. We can write here m v2 square upon r into 1 upon mg is equal to n sin theta plus Fs cos theta upon n cos theta minus Fs sin theta. Cancel out the m factor from left hand side. We get the equation as v2 square upon rg is equal to n sin theta plus Fs cos theta upon n cos theta minus Fs sin theta. We know that the force of friction depends on the speed of vehicle for a given road surface and the tire of vehicle, and it has a maximum limit up to mu s n. So we can write here the force of friction is directly proportional to the normal reactant, and we can make the equation as Fs is equal to mu s n, when mu s is a coefficient of static friction. So just substitute the value of this Fs in this above equation. We can write down the v2 square upon rg is equal to n sin theta plus mu s n cos theta upon n cos theta minus mu s n sin theta. Now divide this equation 4 by n cos theta to the numerator and denominator so that it will not change the value of the equation 4. So we can write the equation as v2 square upon rg is equal to n sin theta plus mu s n cos theta upon n cos theta divided by n cos theta minus mu s n sin theta upon n cos theta. Here you split this term in the numerator as well as denominator and try to get the numerator value and the denominator value. Now n sin theta upon n cos theta, it can be n will get cancelled out and you will get the sin upon cos, and that gives you the tan theta. So in the numerator we can write here tan theta. Also in second split up, mu s n sin theta n cos theta upon n cos theta. So n cos theta and n cos theta will get cancelled out and you will get the mu s value in the numerator. As well as in the denominator, split the values here. N cos theta upon n cos theta, it will get cancelled out and you will get the factor 1 in the denominator minus mu s n sin theta upon n cos theta. Here the n factor will get cancelled out and you will get the value as mu s sin theta upon cos theta. That gives you the mu s tan theta. Hence, by dividing the equation 4 by n cos theta, we can finalize the value as V2 square upon Rg is equal to tan theta plus mu s upon 1 minus mu s tan theta. Here, by considering the same equation, we can get the value of this V2 square as nothing but Rg into tan theta plus mu s upon 1 minus mu s tan theta. So, to get the value of the speed which is greater than the most safe speed, we can write down as a V2 maximum is equal to square root of Rg into the bracket tan theta plus mu s upon 1 minus mu s tan theta. This V2 value will be also considered as a maximum speed value which is greater than the most safe speed on a rough curved horizontal surface. Now in this equation, if the mu s value is cot theta, so we can find out the V max value is nothing but the infinity, and we know that the mu s value is maximum for, and that is comes to be 1 only. So for the theta which is greater than or equal to 45, V max value will be infinity. However, for a heavy bank road, the minimum limit may be very important for the rough curve road. So, we get the two equations for the bank road on a rough curve surface as V minimum is equal to square root of Rg into the bracket tan theta minus mu s upon 1 plus mu s tan theta, whereas V maximum value is equal to square root of Rg into the bracket tan theta plus mu s upon 1 minus mu s tan theta. Now in both the equation, if there is no coefficient of static friction is 0, okay, so that is there is no friction considered, then we get the V value is nothing but the surface speed on a bank road, that is equal to V is equal to square root of Rg tan theta. Just substitute the value of mu s as a 0 and you will get here the numerator value is nothing but the Rg tan theta, and therefore if the mu s value is 0, we get the most surface speed on the curved surface, and that is equal to Rg tan theta.